starting with the great name of Allah, who is the most merciful and beneficent. Myself, Asad Majid, and I am along with my groupmate Abdul Basit, and we are going to present our final year project presentation. The title of our presentation is Plant Leaf Feature Extraction Using Machine Learning with Raspberry Pi as Visual Sensor Node. This project is supervised by engineer Muhammad Irfan Yunus. So first of all, we will be going through the project overview. Then we will be moving to our next topics. So here is our project overview. Our system will be consist of Raspberry Pis, and we will be using Raspberry Pis as visual sensor nodes. What they will be doing with that, they will be capturing images from the field, agriculture fields, and these captured images will be sent to the base station. The base station will be a Raspberry Pi. The medium of communication between them will be the Bluetooth 4.0. We will be using Bluetooth 4.0 because it's a low power version and it consumes less power than the other versions. And the base station will be connected to the internet. It can be connected to the internet using Wi-Fi, and we once the images will be sent to the cloud via Wi-Fi, then we will be pre-processing that images, like we can prepare it, resize it, and we will be converting that images to the grayscale, and we will be giving these images to the classifier, and these the classifier will classify them into crop or wheat, and if the wheat is found, then the real-time alert will be sent to the user via mobile application. So, what is the motivation of this project? Since Pakistan is an agriculture country, so there is a need to utilize these machine learning and IoT. Since we haven't seen such a trend in agriculture that we are using machine learning or IoT, so there is a dire need to implement these technologies in this sector. So we need also a system that can collect and analyze the agriculture field data for site-specific crop management, and we need also to build a decision support system. So here is the objectives of our project: to introduce automation and technology to farming, to implement wireless visual sensor network using Raspberry Pi, and to build an effective classifier for image classification. We will be classifying the crop and wheat leaves, to build decision support system. So here is the system flow diagram of our system. This represent a field, and we will be using Raspberry Pi with camera. So this Raspberry Pi will serve as visual sensor node, and this will capture the images. Then the captured data will be sent to the base station, and it's a Raspberry Pi, and the data is sent through Bluetooth. The base station receives data from sensor node, and it uploads data to the cloud storage. On cloud storage, we will be having a server, and in this instance, we will be having a Google Colab that will fetches the uploaded data, and data will be given to the trained model for prediction. After the prediction is done, is the alert will be sent on the mobile application, because if the wheat is detected, we will be creating an entry into Flutter Firestore. So mobile application will be connected to the Firestore, and if the wheat is found, then user will get the real-time alert, and we will be saving that data for future use. So here is the project complete framework. We will be having the field, and we will be having the sensor node Raspberry Pi. We will be having a base station Raspberry Pi. We will be having a Google Cloud. The base station will send data to Google Cloud, and there will be a classification model that will be doing live classification of the data. Then we will be having Firebase. The if the classification, if the wheat is found, then the fire entry is generated in the Firestore, and the result will be shown on the Android application. So here is our project plan according to our initial presentation. This picture serve as the overall review of the technology evolution of the technology. Before 90s, we will be having all work done manually. Then between 1950s and 1970s, the evolution of machines comes in, and we see tractors and other machines came into existence. Then, before starting 1990s, there came computers, and internet came into existence as well. Then in 1994, we see satellites and sensors are invented. So here they serve as the breakthrough. And we also see that in 2000 there are mobiles, and like we will be having Android and iOS. So the present era is the era of artificial intelligence, big data, and IoT. So we need to leverage these capabilities to in the field of agriculture. So there are many papers that we reviewed in literature review. The first one is the state of the art knowledge of intensive agriculture. So this paper served as a review study on data analytics techniques used in agriculture. The author has reviewed several techniques for to be which can be used for data analytics in the field of agriculture. The second paper is a wireless sensor network for vineyard monitoring that uses image processing. In this study, the author has done is that they have deployed wireless sensor network in vineyard for disease detection. The wireless sensor network was capturing images, and if the disease is detected, then there will be real-time alerts were generated. The disease detection was done using image processing techniques. The third paper is Raspberry Pi as visual sensor node in precision agriculture. In this study, what the author has done is that they has deployed a wireless sensor network in paddy crop field to classify paddy crops and weeds so that weeds can be eliminated. They used different classifier like SVM, KNN, and others, and they also compared their performance. In the fourth paper, early weed detection using image processing and machine learning. What the author is done that they worked on a similar idea, but instead of deploying wireless sensor network, they used UAV images so that the collected data is given to the classifier like SVM and KNN, and the real-time classification can be done.
So here comes the data collection, and the data was collected from various districts of Pakistan, including Dera Ghazi Khan, Khairpur, and Nawab Shah. Around 500 images were collected. These images contained cotton and wheat data equally. The data, and we use mobile cameras to capture these data, to capture these images. So this is the image for the cotton crop and sample image, and this sample image shows the wheat present in the cotton and classification. For the classification purpose, we use CNN, and it has widely used for image classification. The kernel-based approach in the CNN provides good results compared to the ANN. And we didn't use conventional machine learning because it used manual feature selections, which is very lengthy process, and there is much more chances of the error. And the manual feature selection and needs the appropriate domain experts for the feature selections, and we wanted to fully automate the system, so we didn't want any domain expert in this system, so we went for the CNN automatic feature extraction technique. The CNN needs a lot of data, and there is chances that the model may get overfitted. So we use transfer learning technique. For transfer learning, we used mobile net version 2. It requires small data to train an effective model. And the model was already trained, and the model was pre-trained, and we gave our data and retrained the model, and we got the new model for our data. And this shows the results when we were training the model. checking model performance on the test data set. So after training the model, these were the results of our trained model. Around 89% accuracy of the model, and the precision for the model was 1. The recall score of our model was 71%. The F1 score was around 84% of our model. And this is the AOC ROC curve of our model, and it was 0.91, around 91%. And this is the confusion metric for our model. Around 24 images were collectively classified as true positive, and 10% was true negative. Only 4 images were incorrectly classified positive, and these were negative images. So this is the true positive, and only 0 images were classified as a true false negative. Hardware setup. So the hardware contained Raspberry Pi, one base station Raspberry Pi, and other was sensor node. The base station, the sensor node was connected with a camera, and multiple sensor nodes can be created using cameras. This is the Raspberry Pi and the camera connected. And this is the console for our sensor node Raspberry Pi. It shows the whenever an image is captured, and the Raspberry Pi, the sensor node Raspberry Pi connects itself with the base station Raspberry Pi and sends the images. Once the image is sent, then it deletes the images for saving the memory, because Raspberry Pi is very limited memory. It was on the memory card, and then the image is deleted, and then the Raspberry sensor node Raspberry Pi is disconnected from the base station Raspberry Pi, because we set the time interval for testing purpose 1 minute, but it can be varied as per our requirements. We can set 1 image per hour, or we can set it 4 images per minute. The disconnection was done because every time it is connected, it will consume the power. So whenever we have image, we only connect that time the Raspberry Pis together. So when the image was sent, it was disconnected, and again when new image was captured, it was sent to the Raspberry Pi, then deleted the image, and the Raspberry Pi disconnected itself from the base station Raspberry Pi. And this is the console results of the base station Raspberry Pi. It waits for the connection to connect itself, and whenever the node is connected, the image is received, and the node disconnects itself from the base sensor node Raspberry Pi. In this console is the base station Raspberry Pi. So whenever the base sensor node is disconnected, the image is uploaded to the Google Drive, and then also again the image is deleted from the base station Raspberry Pi for memory saving, and then the base station Raspberry Pi waits for the sensor node Raspberry Pi to connect itself with it, and send any images. And this is the live classification kernel of our model. We used Google Colab service for this. Whenever the image was saved on the Google Drive, it directly picks that captured image in this kernel, Google Colab kernel, and feed it to our model. And the model gives the classification results as 0. It is 0. The 0 in our model shows the weed data set, because we had no cotton at the present time. Anything other than the cotton is classified as a weed. So this was a small graphs there. So the model correctly predicts it is the weed. This shows and that how it picks it checks while true until the image is stored in the Google Drive. It directly imports in the kernel. We set 10 seconds time for the kernel to check every 10 seconds if there is an image, import that in the kernel. So whenever the model classifies weed in our data set, so it the weed result is saved in the Firebase Google Firebase results. We have used Firestore database in here. It is NoSQL database which has a document structure, and this shows that there was a weed found in our images. So this shows in March 24, 2022 at 4:26 p.m. The weed was found. The image we captured was classified as weed from our kernel, and the result then was saved in our Firebase. So whenever the result is stored in the Firebase and the weed is found in our live capture images, these results stored in the Firestore are notified to the user through the mobile app. This app was built through the Flutter, and here it says that the bead was found on March 24. So whenever from the live classification, if bead is found, and the user is notified through mobile app, and these are all the results that when the bead was found, the results were stored in the Firebase, and the Firebase directly send the results to this app, and user is being notified.
So here is the conclusion of our study. We have done, we have built an effective classifier to classify the cotton and weeds, and our classifier was able to predict this with 89% of accuracy. And we can improve this accuracy if we have larger data set. For example, if we collect more data set, in this case we were having almost 500 images, but we can improve if we collect a lot of data like thousands of images, then the accuracy and other performance metrics can be improved. And we have trained this model on Pakistani data set, and we can also use other field data set initially we have used Pakistani cotton data set. Then we could train this classifier on like maize crop and other fields. So we will be having a general class, multi-class classifier, so that can be effective in all types of agriculture fields. So after the conclusion, we will be having future recommendations. Future recommendation is that what we can do in the future, that we need to integrate our system with actuators, so that we will be having a robot or something like that that will be cutting the weeds if they found. And we need to also train model for other field data sets, and we need to add other sensors as well. Like in the current scenario, we are using only camera, but we need to use other sensor like humidity, water level, airflow, etc., because these collected data will be helpful. uh, and also we need to improve the security of the system, because we will be deploying this system in an open environment, open field. So we need to also consider the security, and we need to improve that. And we need to also add the safety for the system. And we will be doing a research paper on this topic as well. So these are the references. So thank you.